Thank you for coming to the first Atlas lecture for the new academic season. I will introduce briefly the speaker, Jameson C. Donati. He's a postdoctoral researcher at the Democritus University of Thrace. He holds 2 BA degrees in classical archaeology and ancient Greek from Franklin and Marshall College, and an MA in classical archaeology at Florida State University, and a PhD in art history at the Institute of Fine Arts, New York. His research interests comprise the archaeology of the Greeks and Romans, and particularly urban and rural landscapes of the Mediterranean, and the use of remote sensing and GIS applications to study the past. Dr. Donati has participated in dozens of archaeological fieldwork projects, excavations, field and geophysical surveys, GIS, and remote sensing at places such as Olynthus, Pella, Corinth, Sicyon, Pompeii, Samothrace, Phrodisias, and Amorium. And thank you for coming. The floor is yours.
If I want to advance the slide, I'm assuming, okay, there we go.
Yeah.
Okay, perfect, okay.
Do you need a laser pointer?
I have a laser pointer.
Okay.
Okay, thank you for coming. I'm happy to have a cozy sort of talk, so interrupt me in the middle of things and ask questions, I guess. Just very briefly, I'm planning to talk around 40 or so minutes, so I'm hoping that'll keep you interested through there. Let me just point out that, although I'm talking, there's a humongous group of people that went involved into this project, including one who is right here tonight. So besides me, the primary investigator in the project was Amalia Avramidou, who's a professor at the Democritus University of the Thrace, specializing in classical archaeology. Apostolos Garifalopoulos, who just finished his PhD at the Aristotle University of Thessaloniki. He was one of the leaders for the pedestrian field survey, and he specializes in Roman ceramics. We found a lot of Roman ceramics on this project, so it was great to have him. It just so happens that our fieldwork in Thrace is right at the border between 2 different archaeological efforts. So we have the participation of both the effort of Evru and of Rhodope as well. And so Fenia Pardalidou and Xenia Etardoglu are the representatives of the effort of Evros. Fenia specializes in classical ceramics. She's published a lot on Zoni in Thrace. Xenia specializes in Byzantine ceramics. And from the effort in Komotini of Rhodope, Chryssia Karadima, who's the proestameni, the director there, and Maria Tasaklaki, who's an archaeologist there. She's also done a lot of work at the excavations ongoing at Molivoti. For geophysics, if anyone has done geophysics, is familiar with geophysics in Greece, you'll probably know Apostolos Saris and Nikos Papadopoulos, both at the Institute for Mediterranean Studies, a lab of geophysics satellite remote sensing, although Apostolos has now since moved to Cyprus in digital humanities. He's chairing a program there at Nicosia, but he's still very much active in Greece. So that said, let me start my talk. So the first phase of the Peraia of Samothrace project was active between 2020 and 2023 under the directions of the efforts of Rhodope and Evros in collaboration with the Democritus University of Thrace and the Laboratory of Geophysical Satellite Remote Sensing and Archaeoenvironment on Crete. Thanks to a 3-year grant by the Hellenic Foundation for Research and Innovation, ELIVEC, the project investigated the area opposite the island of Samothrace through intensive pedestrian and geophysical surveys. In classical antiquity, the region was known in the literary sources as the Peraia of Samothrace because of fortified settlements established there by the island in the 6th century BCE. The natural environment of the area is incredibly diverse, in part because the Rhodope mountain range ends quite abruptly into the northern Aegean Sea here. This factor distinguishes the Peraia from the coastal river basins towards the west and east. The terrain, therefore, alternates between narrow coastal zones with small coves, highland streams that feed into river gorges, rugged hills covered with forests, and a limited number of upland plateaus, one of which I showed in the introductory picture. Although the Rhodope Range acts as a natural barrier, it's also the only suitable place where land traffic can pass between east and west, from the Lissos River basin to the coastal plain around Alexandroupoli and extending eastward. Both the ancient Via Egnatia and the modern Egnatia motorway traverse through the mountain passage of the Peraia. Archaeological fieldwork in and around the Samothracian Peraia has documented a diverse range of material culture. Most prominent are the excavations at the Neolithic and later Iron Age settlement of Makri and the fortified settlement of Zoni, a Greek colony preserving houses, sanctuaries, and burials dating from the Archaic through the Hellenistic period. Of the 6 settlements mentioned in the literary sources as comprising the Peraia of Samothrace, only Zoni has been securely identified. The location of the others, Thrace, Mesembria, Sale, and Tempera, are uncertain. Other sites of interest in the Peraia are Vrisi Musa, 2 kilometers west of Zoni, near the remains of a medieval tower, with pottery from at least the 8th century BCE onwards, and the prehistoric pyrite stone quarries near Petrota village. For my talk this evening, I will focus on 2 main themes. First, I will give an overview of the Peraia of Samothrace project, our aims, fieldwork procedures, and an account of some of our findings to date. The second part of my talk focuses on one particular discovery, what we believe is good evidence for a previously unknown Roman station along the ancient Via Egnatia. I should mention that we have published the preliminary results of our work in open access journals and edited volumes, all of which can be downloaded on the project's website, peraiasamothraceproject.gr. In the interest of time this evening, I will pass over much of the literary evidence concerning the Peraia, but I encourage you to download some of the articles for a more in-depth analysis. On the project website, one can also access WebGIS database that provides field data from both pedestrian and geophysical surveys. Broadly speaking, the purpose of the Peraia of Samothrace project is to initiate an intensive archaeological survey to gain a better understanding of the region's human presence, settlement patterns, and land use from prehistory to the 20th century. Within Thrace, the Peraia served as a crossroads between Europe and Asia and the northern Aegean and the Black Sea. It became a melting pot of prehistoric populations, local Thracians, Greek colonists, Persian soldiers, Macedonian and Roman victors, and Christian and Muslim inhabitants. Despite its rich history, the use and occupation of the landscape based on systematic research remains sparsely understood. On a more targeted level, the project aims to provide insights into the Thracians as well as their relationships with the Greek colonists. It is also hoped that we can contribute to the long-standing issues concerning the identification of Samothracian settlements mentioned in the written sources. Lastly, another goal is to develop an appreciation of the Byzantine and Ottoman period landscape. The practical aspects of the a hybrid approach to studying the landscape of the Samothracian Peraia was applied through non-destructive, complementary methods of fieldwork, all within a finite budget. Large-scale and rapid methods of analysis, such as remote sensing and geophysics, were combined with intensive pedestrian field walking. For geophysics, magnetics and ground-penetrating radar were employed to detect and map buried features. For large coverage, we used a multi-sensor magnetometer towed by a quad bike, which you see on the top left. In good conditions, the motorized configuration can cover more than double the area of a handheld system, reaching as much as several hectares per day in coverage. For more targeted investigations, we used a single-channel GPR fitted with a 250 megahertz antenna. To date, the project has surveyed more than 40 hectares of the Peraia with geophysics. The practical aspects of the pedestrian field survey were prepared beforehand using the project geodatabase in consultation with satellite imagery and terrain models. Once on site, GNSS RTK receivers were employed to quickly lay out the survey grids as well as the positioning of field walkers spaced 10 meters apart. A standard survey unit was a grid of 50 by 50 meters to accommodate 5 field walkers spaced 10 meters. The diversity of field systems in certain areas required survey units adapted to the morphology of fields for up to 7 walkers, spaced 10 meters. Field walkers collected all ceramics, tiles, work stone, and other material of potential interest within a 2-meter wide tract. After completing the survey unit, the material was then carefully examined, counted, and weighed, while diagnostic finds were collected for study at the Archaeological Museum of Komotini. For data recording, we created customized XLS survey forms using Esri Survey 123. The forms documented everything from field conditions, location and elevation of survey units, and ceramics and tile counted and collected by each walker. The Born digital approach had the added advantage of being directly integrated into the project's ArcGIS Pro geodatabase and WebGIS. The project marked 4 areas of interest of varied size and diverse topographical characteristics for archaeological investigations. One issue in determining the most appropriate places to examine is the overall ruggedness of the region, characterized by precipitous hills and oftentimes covered with dense vegetation. For practical reasons, such terrain would not have been appropriate for pedestrian field surveying and geophysical perspection. For this region, we largely chose to target agricultural zones. The westernmost of the study area, Area 1, is 2 kilometers inland from the coastline on an upland plateau. It comprises one large open area subdivided into irregular plowed plots with a solitary farmhouse and clusters of cultivated and fallow fields further below. Just southwest of the plateau, exploratory fieldwork during the previous century at an area known as Mikros Eleonas identified a cluster of structures purportedly of classical date, still exposed on the surface among dense shrubs. On the pedestrian field survey, we studied 137 survey units covering an area of 28 hectares. Ceramic finds and tiles were widely scattered throughout the survey area, with chronological horizons stretching from the Iron Age through the early modern era. No in situ architectural features or built remains were noted. The bivariate density map produced from the surface survey displays the intensities of both ceramics and tiles calculated as grams per square meter. Now let me just explain quickly what I mean by bivariate density map. So here we're typically when you have density maps, you will show your ceramic densities as you see on the left, and then you might have another with the tile densities on the right. The bivariate density map allows you to combine the two together. And so you're able to absorb a greater amount of information on the same map. And so here, for ceramics, so going from white to say yellow-orange, those fields, which most of these fields just have these yellow-orange colors, these means they're high densities just in ceramics. Whereas you get to the blue is just the high densities of tile. When you get combinations of both high densities of ceramics and tiles, then you get these different darker brown colors. For example, say up here. So it's the combination of the tile density and the ceramic density. And also we show here where stone objects have been found using the graduated circles. There, yellow circles. So we're actually seeing 3 different things on one map. So we documented the greatest concentration of ceramics at the southern periphery of the plateau, extending to the smaller fields further south, and the north center of the plateau around the farmhouse. The tile information diverged to some extent from the ceramics data, though we recorded a high concentration of tiles around the farmhouse where many ceramics were documented. Few, if any, tiles were found elsewhere. Apart from this evidence, there was notable concentrations of stone objects, such as flints, blades, and stone cores, some of which likely attest to prehistoric activity, which is known in the area. We recorded a diverse assortment of stones and minerals, such as pyrites and quartz, especially among the small fields south of the plateau. What is often characterized as local or Thracian ceramics was present in the majority of survey units, with concentrations especially south and west of the farmhouse and at the southern region. Here we're looking at a basic presence map where through the different chronological periods we're seeing whether diagnostic finds are of this particular date. So the top left is the so-called local Thracian ceramics, which, as I just said, have been found in sort of the majority of the survey units. And then you get much fewer classical ceramics in the one on the top right. The bottom left is showing us the Hellenistic and Roman, and the bottom right is showing us the late Roman and Byzantine. So far, there are no imported ceramics of archaic date from Area 1, but the discovery of fine black glazed pottery, such as fragments of classical cups and craters, represents vestiges of activity in the classical period. In general, the classical material is limited to a small southwest part of the plateau in proximity to Mikros Eleonis, where reportedly there are classical walls. Hellenistic and Roman diagnostic ceramics appear in greater number of survey units, and these finds are well distributed throughout the southern half of the plateau and in the small fields below. Of interest is the shift that occurs with the late Roman and Byzantine ceramics, as they clearly cluster in the north center of the plateau. Based on our preliminary analysis of the pottery, we note significant concentrations of Roman and Byzantine amphoras and a smaller percentage of storage vessels. Tableware is more evenly distributed from the classical through the Byzantine periods, while cookingwares are fewer in number. The magnetic survey in Area 1 covered more than 22 hectares, corresponding to most regions traversed by the pedestrian survey. Features related to long, linear, and curvilinear negative magnetic anomalies predominate and suggest an intense past superficial activity of streams. Clusters of magnetic dipolar features, particularly west of the farmhouse, are indicative of the accumulation of magnetic rocky fragments. And that's in this inset here. You can definitely see that there is a larger cluster of anomalies here as opposed to elsewhere. Here, the pedestrian survey noted an increase in scattered stone material, along with moderate densities of both ceramics and tiles. Although ambiguous in the data, the coarsely rectangular form of magnetic anomalies in the southwest in the bottom inset could plausibly be from subsurface structures. So I know it's a little bit hard to imagine, but these rectilinear anomalies here, especially the darker anomalies, and with dark anomalies, they represent low magnetic features, which may represent stone. And it's conceivable that some of these are stone walls beneath the surface. And this is where we also found an increase in classical pottery. So let's quickly pivot to Area 2 at Petrota Beach. Area 2 is the smallest of the 4 study areas, located approximately 2 kilometers southeast of Area 1. This narrow, fertile plain was formed by the Yalurema River. The terrain is mostly flat except for a small plateau at the northeast. Small summer residences and agricultural fields comprise the area today, while recent roadworks have destroyed a significant section of the surrounding hillsides. Rescue excavations in the 1970s on the small plateau revealed the western side of a rectangular 2-room structure with an east-west orientation and fragmentary walls of other buildings, along with a scattering of Hellenistic and Roman pottery and roof tiles. Few diagnostics were found to adequately date the building or determine its function. Because of its size and orientation, the excavator Evangelos Pantazos tentatively identified it as a temple. So, and you could imagine why you would think that from this. It does look like a small temple, but not completely. The whole building is not completely exposed. The pedestrian survey in Area 2 covered some 6 hectares. The bivariate density map shows that the highest concentration of both ceramics and tiles were found in survey units directly below the plateau. Material was still distributed west of the river, albeit at more moderate levels, and we documented more tiles than ceramics around the putative temple. Contrary to Area 1, here there is little evidence for local Thracian, late Roman, and Byzantine ceramics, while tools and flints are nearly absent. Instead, the survey found large amounts of Hellenistic and Roman pottery, such as transport amphoras, storage vessels, cooking and dining wares, both plain and fine, local and imported, such as West Slope, Megarian, and Terra Sigillata. Of interest is a stamped amphora handle, probably of a local workshop, while the discovery of a pointed amphoriscos and a stone relief fragment are perhaps indicative of the existence of the hero-rider cult during the Roman period. Isolated earlier finds do exist, such as a black glazed handle and the rim of a Corinthian drinking cup, but these are rare examples. The magnetic survey here explored fields in the lower plain on both sides of the Yalurema River. In general, the fields below the plateau produced no clear traces of subsurface buildings, despite the large concentration of surface ceramics and tiles. It is likely that any structures have been largely eroded or buried under deep layers of accumulated alluvial deposits from repeated past flooding episodes caused by the river. And so you see the areas, this river now is small right here, but on either side of that we get very smooth magnetic signatures. And so this suggests sort of alluvial deposits over time have run their course, and that's why we're not seeing much. Over here, it's a little bit higher, the elevation, and what we're seeing here is probably not structures, but we're seeing the bedrock. However, if you look closely, you will find what we believe is a World War I trench here in the middle of this field. We know it's probably World War I because we studied also aerial photos from the 1930s, and that still existed there, and they're probably from when the Bulgarian army was active here in the First World War. So, on the small plateau, however, GPR depth slices show structural elements and building foundations around 1 meter below the surface. A large building or complex of adjoining buildings is located north and northeast of the putative temple, with internal subdivisions, sharing the same alignment with the so-called temple and partly surrounding it. Further east, there appears to be other structural elements, while a reflector about 3.5 meters in length, number 6 on the plan on the bottom, may be interpreted as an eastern extension of the putative temple's southern wall, providing an estimation of about 18 meters for the complete length of the structure. So I think you can see that there are definitely these structural elements, but in general, the GPR data was quite noisy, and that's because these were the conditions for running the survey. It was very bumpy, it was very grassy, there was a lot of rocks and stones lying around. And so when the device is going like this over the ground, you're going to tend to get noisy data like that. But luckily, it was clear enough that we were able to see that this structure here, whether it's a temple or not, whatever that was, it was surrounded or included other structures, either contemporary or not contemporary, with it. Around the plateau, architectural blocks, both roughly hewn and well cut in situ or collapsed, and some still one on top of the other in courses, were noted. These were carefully mapped with GNSS to help visualize their spatial distribution. The initial results showed that the small plateau was probably surrounded wholly or in part by a peribolos, retaining walls or some kind of defensive circuit, while some blocks seemed to come from buildings. The study of orthophotos, historical aerial photographs, and satellite images provides no secure indication of whether sections of this wall continued further south towards the water, with the idea that it perhaps surrounded a larger area like a complete settlement rather than just the plateau. So we weren't able to discern that from the satellite and aerial photographs. When examining jointly the results from Area 1 and Area 2, the results from Area 1 and Area 2 seem to complement each other. Area 2 appears to have been a harbor settlement, perhaps fortified, of the Hellenistic and Roman periods, with traces of earlier activity, but only modest occupation in the late Roman and Byzantine eras. In Area 1, the local Thracian pottery has a consistent presence, which is not the case for Area 2. Here, too, in Area 1, there's more evidence for classical material, although largely confined to regions near Mikros Eleonas, where classical structures have been reported, yet they remain to be studied systematically. There is a broader dispersal of Hellenistic and Roman material in Area 1 that overlaps chronologically with that of Area 2, but it is not until the late Roman and Byzantine periods that a dominant cluster appears to form in Area 1 in the north center of the plateau. Based on the accumulation of roof tiles here, we tentatively view the late Roman Byzantine material as coming from a farmstead whose exact location, despite extensive geophysical surveying, remains to be found. Turning briefly to the question of Samothracian fortified settlements, we believe both areas 1 and 2 are potential candidates for Thrace and Mesembria. Hecataeus of Miletus, as we know from Stephanus of Byzantium, calls Thrace a polis Thracis, while in a decree that was found in Zoni, Poliartos is honored by the citizens of Thrace with free docking and departing from their port, a reference which indicates that Thrace had harbor installations. Also, Thrace was a fortified city, as we learned from Polyanos' description of how the Spartans deliberately demolished the city walls when under siege by the Athenians in order to inspire their men to fight courageously. The characteristics of the site at Petrota Beach in Area 2 match that of a possible fortified harbor town in the vicinity of Zoni. Mesembria, on the other hand, could plausibly be identified with the site at Mikros Eleonas, although the limited fieldwork there does not carry us much beyond a reasonable theory. Mesembria was the westernmost of the Samothracian settlements, and most probably the shortest lived, since it is only mentioned by Herodotus and no other source. Of all the study areas, we investigated the most survey units and covered the most ground in Area 3. It is a much larger area located 5 kilometers inland from Zoni and expands around 2 farming villages of Peraia and Komoros. The topography is dominated by 3 summits, Mavropetra Hill, and then 2 hills, one called Hill 319 and the other called Hill 339, based upon their elevation. Rescue excavations on Mavropetra Hill, in anticipation of the expansion of gold mining in the area, produced mostly local pottery and material related to the cult of the Thracian horsemen, while Hill 319 preserves in situ architecture and collapsed walls from structures and fortifications. The ruggedness of the hill, densely pocketed by vegetation, did not enable us to study the remains during this phase of fieldwork. Elsewhere, sections of the Via Egnatia, the Roman road that connected the Adriatic Sea to Byzantium, are visible east and northeast of Komoros. Even though much of Area 3 remains to be studied, some general characteristics have started to come into view. Ceramics and tiles were well dispersed with chronological horizons ranging from the prehistoric through the Ottoman era. However, most surface finds were squarely of late Roman and Byzantine date. The bivariate density map shows a fairly broad dispersal of surface material around the villages of Peraia and Komoros, while some districts produce few, if any, ceramics, for example, the region northeast of Komoros. Moderate density levels of surface pottery in general pocket the terrain. High density levels of ceramics were less frequent and were often confined to only a single survey unit or pair of units, but they were nonetheless visible in the data. The present-absent maps from Area 3 reveals a significant upward trend in the exploitation of the landscape by the middle of the first millennium CE compared to earlier periods. Diagnostic examples of late Roman and Byzantine ceramics were plentiful, and they likely represent small farmsteads, permanent or seasonal, spread around the countryside. Post-Byzantine and Ottoman ceramics were also represented in the data, which alludes to a continuation in the agrarian use of the land. A concentration of Neolithic pottery was identified in survey units northwest of Peraia, which is on the map here, AOI 1 up here. And the assemblage forms the earliest ceramics material discovered to date on our project. Diagnostic examples of both local wares of archaic and classical ceramics were generally scarce from Area 3, although we did find a fragment from an SOS amphora of the 6th century BCE. Hellenistic and Roman diagnostic ceramics were documented in a greater number of survey units, mainly concentrated in 2 places. One, about 400 meters northeast of Hill 319, and another along the Via Egnatia, north of Hill 339. In the first example, which is labeled as AOI 2 on this plan, we found pottery comprising primarily of Roman cookware, storage vessels, and terra sigillata, the latter dating between the 2nd and 6th century CE. The type of material alludes to a Roman farmstead at this location. However, only low to moderate tile densities were recorded from the same survey units. Therefore, it seems plausible that any structural remains, if surviving, are to be found further up the small hill, which could not be surveyed because of the vegetation. Concerning the second example, that which is labeled as AOI 4, near the Via Egnatia, I will elaborate very shortly on this, since the material seems to be from a Roman station. The area of Neolithic material in Area 3 was further targeted with geophysics. Here we see with magnetics. The magnetics survey produced no obvious signs of a prehistoric settlement or subsequent occupation, such as an enclosure ditch. The data did identify possible pits, represented as roughly circular negative magnetic anomalies, and clusters of dipolar features that may plausibly be anthropogenic, perhaps daub structures. However, it is still ambiguous what, if anything, these anomalies represent. Finally, Area 4 is an expansive and arable coastal plain between Zoni and Macri. The hilly northern rim of the area is defined by the villages of Mesembria and Vicala, which command the coastal plain. The remainder of the coastline is rather flat as it gradually descends at Vicala Beach. Although never systematically studied, the effort of Antiquities of Evros has documented Hellenistic, Roman, and Byzantine material in some fields prior to development. Among them, the area west of Mesembria, known as Sidro-Pigado, stands out, with some scholars tentatively suggesting an identification with the Roman station Malalico, as it is known in the sources. More on this later. Most of Area 4 remains to be explored with pedestrian surveying. Our investigations to date focus primarily on Sidro-Pigado. Here we surveyed a total of 20 survey units. Ceramics were documented in nearly every one, while tiles were found in the majority. The latter hints at the existence of structures in the vicinity, either loosely scattered around or more concentrated, as in a settlement. Though few, if any, worked stone material was identified on the surface, small to medium-sized unworked stones were abundant in many of the fields, and they could plausibly be from ruined structures. The chronology of the diagnostic surface material recovered from Sidro-Pigado favors almost exclusively a late Roman and Byzantine date for the areas surveyed. Ceramics of these dates were plentiful and included glazed Byzantine plates and bowls, late Roman and Byzantine amphoras, and coarse storage vessels. Plinths and tiles with scoring patterns were also plentiful. Later material was largely absent, as post-Byzantine or Ottoman ceramics appeared in only a handful of places. So Sidro-Pigado seems to be mostly of late Roman Byzantine date. The magnetic survey here covered some 2.6 hectares. In general, we observed moderate to noisy magnetic gradients in many places. Several anomalies appear to be the remnants of anthropogenic activity, but without clear definition. In the southwest fields, a curvilinear anomaly extends from west to east and seems to correspond with a linear anomaly in the adjacent field with a similar orientation. And I'm talking about this anomaly that you see here, running here in a curvilinear formation, and then it joins here in kind of a more straight line. These features are approximately 5 meters wide and characterized by low and high magnetic gradients, distinguishing them from the surrounding soil matrix. These are in all likelihood the remains of a roadway passing through Sidro-Pigado in an east-west direction. The 5-meter width of the anomaly would also support an identification as a roadway. So now let's jump right into the Roman station that I mentioned earlier. In 2022, during the survey of fields near known traces of the Via Egnatia, northeast of Comoros, our team collected large quantities of tiles, pottery, and other objects dated primarily to the Roman period. Further exploration of the fields around the Via Egnatia through geophysical prospection generated positive results for buried structures. Structural remains appear in magnetics, which we see on the right, although less distinct compared to the results of ground-penetrating radar, which we see on the left. GPR revealed clear architectural remains around 1 meter below the topsoil, which belonged to a large rectangular complex around 60 by 25 meters in size. The western side appears to consist of a large courtyard, a stoa-like corridor, and possible smaller rooms. If not rooms, the projections along the western wall could be interpreted as buttresses, while the 5 by 5 meter space at the northwest could be identified as a tower. So I'm talking about here, this open area here, and then we see a clearly defined corridor, portico, and then on the northwest you have this sort of 5 by 5 meter projection, and then these sort of buttress features coming out of the wall over there. On the eastern side, traces of rooms and a smaller courtyard appear. The end here is defined by a long rectangular portico or corridor around 27 by 40 meters in size. So I'm talking about this for that long sort of corridor or another portico-like structure. Beyond the main complex, geophysics identified other architectural remnants, probably of detached structures. One of these has a peculiar semicircular shape. The interpretation of geophysics, and it should be stressed that our interpretation is preliminary in the absence of investigations, is suggestive of a large, possibly fortified facility with one or more central open spaces, semi-protected areas, and smaller divisions with ancillary structures. Such a spatial arrangement is suitable for providing shelter to people, livestock, and cargo, allowing for social interactions, but also privacy and defense. Based on all this, an argument can be made in favor of this complex being a Roman station, based on the following, which I will talk about and elaborate on. First, its proximity to the ancient road and its orientation parallel to the Via Egnatia. Its size, it's at least 1,200 by 1,400 square meters, and its spatial arrangement comparable to known North Aegean farmsteads. The finds collected during the pedestrian survey and their chronology, particularly the large amounts of table and cooking wares, and the majority of finds fall squarely from, say, the 1st century BCE till the 3rd century CE. And finally, an analysis of Roman itineraria with a focus on the distances in Roman mileage between the civitates, the cities, the mansiones, the stations, and the mutationes, the stations for changing horses, mentioned in the section between Maximanoupolis and Trianoupolis. A comparison to large rural facilities and the limited archaeologically attested stations in the North Aegean helps identify certain common features with the complex at Comoros. Similar structures serving multiple farming, agricultural, and other activities have been excavated by Zanavari at Lette and by Adam Veleni at the area of Asprovolta, one of which expands in a gamma formation and has been interpreted as a mutatio of the Via Egnatia. According to Dimitris Samsaris, mutationes such as the Byzantine fort at Kalides near Asprovolta and the ones discovered near Petropigi in Kavala and at Megopisto in Rhodopis were orthogonal in shape, extended in an area between 450 to 650 square meters, and were fortified with towers. These road stops were either on the Via Egnatia or less than 500 meters away from it. In the case of a mansio, such as at Acontisma at Kavala, the hilltop settlement was the station itself. As a permanent habitation locale, it covered a large area and was fortified. The suspected station at Comoros appears to be a complex with an orthogonal plan, has double the size of the above mutationes at 1,200 to 1,400 square meters, and may have been fortified. It is located right on the Roman road at the entrance of the ridge that cuts across the Zonia Mountains. Furthermore, it is near Hill 339, a Hellenistic Roman hilltop site overlooking the Via Egnatia, investigated in the past by the effort of Antiquities of Evros. The ceramic evidence and other finds recovered during the intensive pedestrian survey add additional to support in identifying the complex near Comoros as a Roman station. We collected large quantities of tile and pottery, as well as glass, stone, and metal objects. The ceramics date primarily between the 1st century BCE and 3rd century CE, with other finds pre- and post-dating this time frame. They include many table and cooking wares, but also trade amphorae and plainwares. A large percentage, 30% of the diagnostic pottery, belongs to tablewares. Equally high is the percentage of cooking wares, 20% of the total, and of trade amphoras at 15%. Another 35% belongs to plain everyday vessels. Based on the high percentage of table and cooking wares and wine amphorae, an argument can be made that dining and drinking were key activities at this site. A closer look at the tableware reveals that cups, plates of the well-known sigillata production of Pergamon, that is Eastern Sigillata C, are dominant, dating from the 1st to the 3rd century CE. Their clay is the characteristic soft pink of the workshop's late phase. Of special interest is a fragmentary plate with the stamp Eros inside a tabella ansata, belonging to the same production and dating to the time of Tiberius, or maybe later. The cooking vessels show the same chronology and consist of well-known Aegean types. For example, Hythrae with clearly formed outturned rims, and shallow pans with horizontal rims. Small knotted lids are also present among the finds. In the same context, storage and perhaps commercial activities are attested for the period between the 2nd and 5th century CE, from a significant amount of trade amphorae and other storage vessels, as well as a possible metal scale, which you see in the bottom right. Among the amphora, we find examples of a well-known Aegean amphora type, Middle Roman amphora 5 or Zeist 80, with characteristic high rims and heavy cylindrical fluted handles, dating from the 2nd to the 4th century CE. Moreover, there are sherds from the body of grooved amphorae of different clays, which could belong to known amphora types of late antiquity, such as LRA 1, 2, and 4. Lastly, some flattened rims and wide bases belong to large dolia. The rest of the common pottery included vessels for preparing and serving food, such as large and deep basins with various types of flattened lips, jugs with trefoil-shaped rims, prochi, and other cups with 1 or 2 handles. Sorry, I got ahead of myself there. In the 3rd to 4th century CE belong also a few lamps, such as a fragment with a relief dolphin, which could belong to an attic workshop, and some fragments of colorless glass vessels. Together, the tableware, pottery, cookingware, storage vessels, trade amphorae, lamps, and glass vessels attest to the site's character of accommodating a rather large number of people over a long period of time, mainly in the Roman imperial period. Now, as we get towards the end here, following this overview of finds from what we believe is a good candidate for a Roman station near Comoros, we present some preliminary analysis on the site's broader context using GIS spatial analysis. More specifically, we utilize least cost path and least cost corridor models to reconstruct the possible pathways of the Via Egnatia in this region of Thrace. Leaving aside the technical properties, in short, analyses such as least cost path offer predictive models of movement by taking into consideration various environmental factors. Here, we consider 2 main elements using the TandemX digital elevation model from the German Space Agency at a resolution of 11 meters. First is the slope of the terrain, where the slope has a direct correlation to the speed a person can walk. And secondly, hydrological features, such as rivers and streams, where a person's progress is slowed down or even impeded. The result is an accumulated cost model that identifies the quickest or least costly ways to get from point A to point B. Additionally, we exclude terrain slopes in our analysis of 20 degrees or more as possible pathways, as well as terrain within 20 meters of steep ground. 2 stations in the region are known from Roman itineraria of the 4th and early 7th centuries. These are Maximanoupolis, or Porsulus, west of Komotini, and Traianoupolis, east of Alexandroupoli. So these are known. Between them, the itineraria list 5 unknown additional stations, with the Roman mileage given between them. So here, very briefly, I'm showing you just a table of the Roman itineraria. Here we have 4 examples, and the ones that we're going to be looking at are right here between Maximinopoli and Traianoupoli. Not all the stations are listed in every single itinerarium. The early 7th century one has all of them, and you will note that sometimes the mileage between them differs slightly. Archaeologically, sections of the Via Egnatia itself are evident in the foothills around Mesti and Comoros. And that is what I have in red on the plan, the known sections where you can physically see it on the surface today. And there's also a small segment in the eastern suburbs of Alexandroupoli, which I also, you see that as a tiny little red dot right there. That's a known section as well. Although the exact location of the other stations are unknown, Francois Motat, Polixeni Tatopoulou, and the authors of the corpus of inscriptions in Aegean Thrace have convincingly argued that Makri should be identified with Sali and Alexandroupoli with Ad Unimpara or Timpero. Based on the list of stations and mileage, this scenario would mean that the remains near Comoros are possibly that of the station called Malaliko or Milolito. There are no direct architectural remains yet for stations at Makri and Alexandroupoli. As test markers for analysis, we use the Byzantine walls at Makri for Sali and Roman burials at the western end of Alexandroupoli for Ad Unimpara. From the suspected station at Comoros, the least cost path continues southward through the Zonia Mountains and cuts in a southeast direction between the villages of Mesembria and Vikela before arriving at the coastline and finally Makri. It is notable, I think, that the least cost path follows the known segments of the Via Egnatia in the Zonia Mountains. So here, of course, the black is what is the least cost path to travel here. And you'll see how, at least here, it overlaps almost perfectly with the known sections of the Via Egnatia. After Makri, the path continues, not surprisingly, along the coastline until reaching Alexandroupoli. In Roman itineraria, the distance between Malaliko and Sali is 8 Roman miles, while the distance between Sali and Ad Unimpara is listed as 7 Roman miles. 1 Roman mile equals about 1.48 kilometers. The least cost path analysis shows a good correlation to these distances. In fact, our results deviate only 200 meters and 140 meters from the Roman mileage between the 3 stations. Now, the least cost path provides only a single solution for the best possible route. If we expand the range to include the top 2% of possible pathways, here using a least cost corridor analysis, the possible range of the Via Egnatia falls within a similar network, traversing south and southeast through the Zonia Mountains and hugging the coastline after Vikela. The narrow range of pathways in the Zonia Mountains suggests that good terrain for a mountain pass was limited, something of which the Romans were probably quite aware of. So you'll see that in the least cost corridor, it's a very limited corridor through these mountains because presumably, based upon the input data that we have, there are very few other good alternatives for traveling. Whereas once you reach the flat terrain of the coastline, your options expand because it doesn't cost as much. It doesn't incur as much more of your time to go closer to the coastline or a little bit up from the coastline because the terrain is fairly flat there. Looking at the westward projection of the Via Egnatia, there is little evidence for its path before reaching Maximinopoulos, beyond the known segments around Mesti. 2 potential sections are the early Byzantine Castro Arsacchio, near the village of the same name, and a Middle and Late Roman bath complex near the village of Ariana. So what I want to do is to test these as possibilities for being a Roman station. Our interest is to locate the station before Malaliko, called Brindisi, in the itineraria, at an interim distance listed as being 12 or 15 Roman miles. Castro Arsacchio is probably not the station called Brindisi, because it falls many kilometers short of the reported Roman mileage. The Roman bath at Ariana, however, is a more attractive option. At 21 kilometers, the least cost path distance falls within the 12 and 15 Roman mile range. This path follows much of the known segments of the Via Egnatia in the Zonia Mountains before continuing in a northward direction along the eastern side of the flood basin, and in fact, it passes by Castro Arsacchio. Another factor to consider is the distance between the Roman baths, if we are to see this as the possible site of Brindisi, and Maximanoupolis or Porcellus, which the 4th century itineraria list as being 20 to 21 Roman miles, or around 30 to 31 kilometers. The least cost path analysis suggests a route of 30.5 kilometers that traverses the northern edge of the flood basin, passing just north of Como Tini. Using the least cost corridor, again a 2% threshold, the Via Egnatia may in fact have passed through Como Tini on its way to Maximanoupolis. The early 7th century itinerarium identifies another Roman station halfway, or 10 Roman miles, between Brindisi and Maximanoupolis called Breirfarar. There is not yet any evidence for the station, but we should expect it to lie somewhere between the villages of Roditis and Lambro. To sum up here, the results of the geophysics near Comoros and the ceramics collected from a pedestrian survey reinforce our interpretation of the site with a Roman station, while our GIS spatial analysis supports an identification with the Milolito station of the Roman itineraria. Furthermore, the Via Egnatia appears to have stretched from Maximanoupolis through Como Tini until Ariana in a straight line, hugging the mountain slopes and consciously avoiding the flood basin. From there, it seems to have turned southward, passing by Arsacchio through the Zonia Mountains, veering eastward as it approached Vicola before it continued its coastal course towards Traianopolis. This model of long stretches of road deviating only at Zonia brings to mind the description of the 16th century traveler Pierre Bellon, who said, "The longest ancient straightway between Rome and Constantinople unfolds between Como Tini and Kypsola." So there's two things I want to end with here. One, of course, is to highlight here the immense support we have from the students at the Democritus University of Thrace, undergraduate students, as well as some graduate students and some students that came elsewhere. One of them who is here today, Amanda Ball from UNC, who was with us for some time on the survey project. So needless to say that this project was done right at the heart of COVID. So it was very challenging to organize field work like this. Things had to be canceled and rescheduled, and protocols had to be followed. Our first day of field work actually only lasted a day before a general lockdown took into place. So it was quite challenging to get through it, but we somehow managed to do it. And we couldn't have done it, of course. We couldn't have done it at all. We wouldn't have found anything without the support of the students, undergraduate and graduates who volunteered for us. And I'd also like to comment on what are the future plans of this research project. So it hasn't ended at this point. So right now we're focused on continuing to examine the ceramics and the material collected in the Museum of Como Tini, and we're focused on continuing to publish the material with the focus this upcoming year publishing the material from what we think is good evidence for a Roman station. But you can let me know. We'd be happy to hear what you have to think about that. Long term, we're thinking about a second phase of the project. It's contingent upon funding and many other factors. There are many areas that we have yet to explore with pedestrian field survey. We have to continue exploring primarily areas 3 and 4. There's a lot to do there. Continuing with geophysics, it's possible to say target geophysics in areas where we think from, say, least cost path analysis, the Egnatia pass through, to see if we can actually find evidence for that. We'd love to do LiDAR here. As you probably noticed from a lot of the images, this is a very densely vegetated area, very rugged area, where it's just not possible to do field walking. It's not possible to do geophysics. It's not possible to do normal remote sensing using satellite images or aerial photos. And so LiDAR, that is being able to perhaps penetrate through the vegetation to see what material still lies above the ground. And we know, for example, in Area 1 at Mikros Eleonas, there are structures there. We have sort of walked as best we can through there, and they are visible on the surface, but there's a lot more that is covered and just simply not visible. So we think that LiDAR will greatly help us in that. And then finally, the plan is to start excavations. First, around the so-called temple in Area 2 to find out whether is this actually a temple, what are these other structures that are sort of on this complex. That plot is actually owned by the Greek state already. They expropriated in the 1970s. So the logistics of that are a little bit more feasible in the immediate to midterm. Our more longer term goal would be to excavate where the possible Roman station is. That'll be a little bit more difficult simply because that still is privately owned, that agricultural plot. And so something like that, even if the owner is willing, this is something that could take several years or longer to see through. So that's just to let you know what kind of, our goals beyond what we have done right now are. So I thank you, and I hope that I didn't go too long. And for those of you watching later online, hi.